Welcome to Chapter 7, Lesson 1. Today what we're going to work on is solving two-step equations and review what we do in certain situations when an equation is present. So the first thing that I want to take a look at is just a quick reminder of what inverse operations are. If we see a problem that is an addition problem, such as x plus 4 equals 8, what we need to remind ourselves to do in an addition problem is to do the inverse of addition, which we know is subtraction. If we have a subtraction problem, such as x minus 2 equals 10, the inverse of a subtraction is addition, so we would add 2 to both sides of the equation. And if we have a multiplication problem, such as 2 times x equals 14, the inverse operation of multiplication is division, so we would divide both sides by 2, which would give you x equals 7. And then if you have a division problem, the inverse of a division would be multiplication. Now your division problems can be written a couple different ways. One of them might be like this, where you have x divided by 2 equals 8. Because it's dividing by 2, we would multiply both sides by 2. You might also see the same problem written like this, and again, you're still dividing by 2, so you would still multiply both sides by 2. Now, as a quick review of one-step equations, we've got one of each type here. We've got an addition problem. So the first thing that we're going to do is we're going to identify the variable. All right, so we have plus x. So what is on the same side of the equation as x, and what is happening to it? So what I mean here is we have 2 with x, and it's addition. So to undo plus 2, we have to subtract 2. So that would cancel that out. 8 minus 2 is 6. Drop down the x equals 6. In my second problem, I have a subtraction problem. So again, identify your variable x. What is on the same side as the x? Minus 4. The inverse of minus 4 is to add 4. But what you do to one side of the equation, you must do to the other. So we're going to add 4 to both sides. That cancels, and x equals 16. On our multiplication problem, again, I want you to identify the variable. What's right next to the variable is the number 4. Because there's no operation sign, we assume that it's multiplication. To undo multiplication, the inverse would be division. So we're going to divide both sides by 4 because 4 is being multiplied to x. So to undo that, we have to divide by 4. It cancels that out because 4 divided by 4 is 1. 1 times x is still x. So now we have x equals 3. And then our last problem says x divided by 3 equals 9. So we identify the variable, which is x. We're dividing by 3, so the inverse of dividing by 3 would be to multiply both sides by 3. That cancels out. You're left with x equals, and then 9 times 3 is 27. Now, what we're going to be working on today more is working on two-step equations, where you have to simplify one side of the equal sign before you start to solve any equations. So what you'll notice here is on this side of the equation, the equal sign, we have 15x minus 8x. So we have to simplify that down. 15 minus 8 gives me 7. So we have 7x. And then there was nothing with the 49, so that drops down. Now we have a multiplication problem because it's saying 7 times x. To undo multiplication, we have to divide. Because 7 is being multiplied to the x, we're dividing both sides by 7. That cancels. 49 divided by 7 is 7. And then the x drops down into x equals 7. Now in this problem, you'll notice that on one side of the equal sign, I have two things, but one of them has an x and one of them doesn't. So I can't combine those together like I did in the last problem. So instead of simplifying that, what I have to do is I have to identify how can I move this minus 3 to the other side of the equation so that x is by itself. So to start with, we're going to add 3 to both sides. Add 3 there and add 3 here. Now the negative 3 with the positive 3 cancels out, and then 22 plus 3 equals 25. We drop down the 5x. Now some of you might say, well, why didn't we divide by 5 first? Because it says 5 times x. In solving equations, we do the reverse of the order of operations. So normally in order of operations, we know that we're going to do multiplication and division first, and then addition and subtraction. But whenever we solve equations, it's the reversed. We start with subtraction and addition, and then after subtraction and addition, then we move up to division and multiplication. So you go in the reverse order. So now we're left with 5x equals 25. It's 5 times x. So to undo the multiplication, we have to divide. We're going to divide both sides by 5. Therefore, 25 divided by 5 gives me 5, and x equals 5. I always want to make sure that I say x equals. I don't want just the answer of 5. Now in this problem, you'll see that there's lots to simplify. So first of all, we have our equal sign here. We need to simplify everything on the left side of the equal sign first. So we need to identify what other numbers have that x. Well, these two have an x, but the 2 doesn't. So we need to start off by doing 12x minus 15x. Well, 12 minus 15 is negative 3x. We still have plus 2. And then we also look at the other side of the equal sign. We can simplify that. 8 minus 15 is going to give me negative 7. So then from here, I look at the left side of my equal sign again, and there's nothing to combine. So then I think reverse operations. So what's the inverse operation of adding 2? Subtracting 2. So we're going to subtract 2 from both sides. That cancels. We didn't touch the negative 3x, so it stays. It just drops down. And negative 7 minus 2 is negative 9. The last step that I need to do is divide by negative 3 on both sides. This cancels. You're left with x equals. We know that a negative divided by a negative is going to result in a positive answer. So I have x equals 9 divided by 3 is 3. So x equals 3. Our next problem, again, we've got things that we have to simplify first. So negative 3 minus 9 gives me negative 12. I also have plus 24, and those are all like terms. So negative 12 plus 24 actually gives me a positive 12. I also have over here on the other side of the equal sign, negative 2x plus 8x. When I put those together, I get 6x. Now, it does not matter what side the variable is on. This 12 equals 6x is the same thing as if I wrote it as 6x equals 12. So if you want to flip the entire equation so it looks like this, that's completely fine. From here, I have a multiplication problem. So I have to divide both sides because the inverse to multiplication is division. Divide both sides by 6, left with x. 12 divided by 6 is 2. Now, if I would have solved it the way that it was originally set up, I'm still going to divide both sides by 6. This cancels. I drop down the x, but 12 divided by 6 is still 2. But when we read it, we don't read it as 2 equals 6. We read it as x equals 2. All right, so now what I would like for you to do is I would like for you to pause the video and try both of these problems on your own. When you are finished, start it back up again and check to see if you are right. Alright, now that you have solved the problems, I'll go ahead and start this one for you. So the first thing I need to do is combine my like terms of negative 6x plus 4x. That gives me negative 2x. I still have minus 2 and I still have equals 16. I have to reverse that negative 2, and the inverse to negative 2 is adding 2, so that cancels. I'm left with negative 2x equals 18. The last thing I need to do is divide both sides by negative 2, and a positive divided by a negative is a negative. That cancels. X equals negative 9. The second problem, I have to start off by simplifying 18 minus 20. Well, 18 minus 20 is negative 2. I still have positive 5x. And then I drop down the equal sign and the 8. I have to add 2 to both sides of my equation. This cancels, leaves me with 10 on the left side of the equal sign. Drop down the 5x because the negative 2 canceled out by doing the inverse operation. And then the last thing I need to do is divide both sides by 5. 5 divided by 5 is 1, so all I'm left with is 1x. 10 divided by 5 is 2, therefore x equals 2. Now, on this last slide, what I would like for you to do is I would like for you to work out these 3 problems. When you're finished, raise your hand and I'll come by and check, and then we'll go from there. If you have any questions on any of the problems that I've shown you in this video, please don't hesitate to ask, and I'll try to help clarify any questions that you might have.